Hi, my name is Mr. Ticehurst. I'm a computer science teacher at Haydon School, and we're going to be talking through what the A level in computer science looks like here. It's primarily designed to help students understand what the core academic principles of computer science are. That's quite a vast topic to unpack, which we'll do so soon. Classroom learning is transferred generally into creating real world systems through largely the creation of an independent programming project. We'll talk more about that soon too. Students will develop their technical understanding and their ability to analyze and solve problems using computational thinking within this course. Now, this course is broken down into three major components. There is a Unit 1 and a Unit 2, which are both exam assessed, worth 30% each, although a large part of the unit is broken down into a big programming project, which contributes to 40% of the final grade. Now, the first unit, as you can see, we, in this order, cover what components actually are inside computers, how they work, what their role within a computer is. We then look at the software that is run upon these components that users actually utilize and interact with. We then talk a bit about software development. Having just talked about software, it's important that we cover what the actual process is that leads to its design, its development, and what skills the students themselves can start to pick up to assist them in potentially developing their own software. Theory wise, we then continue on to look at how data is communicated between different devices or even within the computer, looking at how the different components talk to each other. The same then, how do devices communicate with each other over networks, whether those are networks spanning small areas within a business or whether they are spanning the expanse of the globe. We'll look at what the techniques are for that and what different technologies allow that to happen. Data types and structures, we start to lead into Unit 2 at this point, which is very heavy on thinking computationally, designing algorithms, and actually looking at what some examples of complex problem solving algorithms already exist out there. Still in Unit 1, we look at what the different data types and structures are used within programming, though. Boolean algebra, we look at how we can use logic gates and some engineering theory to evaluate and create very complex logical systems. And we wrap up the unit by looking at ethical, moral, and cultural issues, essentially, how computer science has affected the world at large in a variety of different ways. Unit 2, as I said before, we look at computational thinking, the problem solving process that is very universally applicable to any part of life, not just computer science. And we look at what typical program techniques and algorithms are used within the field. The programming project is huge, and that will actually give students complete freedom to plan, design, and implement their own game. The inspiration they draw from this can be completely up to them, and they need not finish the entire game, so they can set their aspirations as high as they want. We are only interested in the amount of effort that they put towards it, and ultimately how much they challenge themselves and how complex of a system they deign to try and create. Now, computer science is obviously an extremely hot topic in modern society, and we have a massive array of different positions that computer science can lead into. This array is only increasing every year, but as some examples here, you can see I've got a list in front of me: artificial intelligence, computer communications, cybernetics, forensics, virtual reality, computer systems. Are the kinds of degrees that you can go to pursue following education at an A level with a computer science course. Careers, we're looking at app developers, people that make the games and the applications you use every day. Cybersecurity, massive concern, keeping things safe on both a private and a government level. Application analyst, you can get into more of a design based field. Data analyst, working with crunching numbers, efficiency. Database administrator, working on how computers and machines can all record, search, catalog data. There's so much more. Games designers, games developers, they're huge, huge fields at the moment, and that it's not just the curriculum. We try to throw a few extra things in here as well. You get the opportunity to make your own computer game. We try to get everyone up to the Game Science Museum over in Berlin. It is huge and it is cool. There are robotics competitions all around London that we can link students up with and get them connected to. There's a program that IBM runs, and there are virtual trips. Amazon actually takes through virtual tours of how their infrastructure works, what their databases, what their big warehouses look like, what their programming centers look like. There's just tons of extra little things that really complement the program. Now, I'm going to wrap up my end here with the skills that generally you'll walk out of this course with. I've tried to keep the list relatively small because I think these are the key aspects that you'll be able to take away with you. Critical thought, problem solving, the ability to actually design and develop an application of your choice, technical knowledge in what computers are, how they work, and a really good modern understanding of what the environmental, ethic, cultural, social impacts of technology really are. I have a testimony from a current student pursuing an A-level course, and we've asked him a few questions that I think will give you the student perspective on the course. So I'll play this now.
So why did you choose to study A-level computer science? Well, I think I chose to study A-level computer science because I've always enjoyed working with computers in my own time and also in lessons in GCSE and before. And I think I want to study it in university and then in future pursue a career in it. So I think it was a good choice. What is your favorite part of the course? I think my favorite part of the course is the coursework that we begin at the start of year 13, uh, where we're allowed to make more or less whatever we want, and we're examined on our documentation and our development process. And I think it really, because we can do more or less whatever we want as long as it's kind of within the guidelines, it allows like people to really get their like creative juices flowing as in a way that like no other course or even coursework really does, because you're allowed to do whatever you want. So in my case, I'm making a game, but you're able to, for example, if you've got say a problem with a particular thing and you really want to make a solution for it, the course is uh, well suited to that, and you can do that if you want. Which part of which part is most challenging for you? I actually find the coursework that I just mentioned to actually be the most challenging part because it's also very independent. You're While you do have a rough guideline as to what you kind of need to be doing, it's still up to you to actually get it done and do it how you want to do it. It means that you aren't getting your held hand completely all the way through, but guidance and help is there when you need it. What do you plan to do after sixth form? I plan to go to university for computer science. Why would you recommend the course at Haydon? So I think, well, I would recommend it partially for the reasons that I've already mentioned with the coursework and how it's very, it gives you more ways to work that are different, and it's not something that you can do in like really any other subject. Whereas something like maths, you need to learn your different methods and just make sure you can answer exam questions well. With the coursework here, we can really do what you want and be creative. And as for like the other parts of the course, the theory, I think it's still very interesting and relevant to our lives, whereas sometimes other things are a little bit too disconnected.
So that is a current student's perspective on the course. Now, that's essentially the end of this presentation I've got for you here. But obviously, if you do have any bigger concerns about what the course entails or what you might grab out of the course, the specification is obviously available online. And other than that, we look forward to seeing you here. Thank you.